Quantum computing is not just better computing, faster computing. It's a different kind of computing. It's predicted to solve some of the world's most fundamental problems, from inventing new drugs to making brand new materials and creating more precise climate models. It could solve some problems in seconds that would take current supercomputers thousands of years. The technology is in its early stages, but the effort is quickly gaining momentum. So how will quantum computing change the world?
A standard computer might have billions of bits. Each one can be a 1 or a 0, and they're all completely separate from each other. Quantum bits, or qubits, work differently for a couple of reasons that come from quantum mechanics.
Thanks, Jason, but let's not go down that rabbit hole. All you need to know is this.
The theory shows that certain kinds of problems, not all, just some particularly thorny ones, are made much easier when you've got quantum computers. One of those problems is in encryption, the kinds of codes that protect your credit card details online or your messages in WhatsApp or Signal. What got people really interested in making quantum computers was the realization that they could break encryption that was supposed to be too hard to crack because regular computers couldn't crack them. That's the kind of thing that gets the attention of national governments, the ability to crack other countries' encrypted networks. As in the case of artificial intelligence, China says it intends to lead the world in quantum science and has announced plans to open its own national quantum laboratory to open in 2020. America is getting involved too. It intends to create a national quantum initiative. That's because the prize that quantum computing offers, the potential strategic or commercial advantage, is huge. Imagine if you could make minute-to-minute, real-time stock predictions based on data from every trade ever made. Or if you could simply compute the formula for a new fuel or a drug that beats a horrible disease. That's the kind of promise that quantum computing may offer. There are already quantum computers out there, but it's a bit like the situation with regular computers in the 1950s. Big basement-sized things that required a pile of PhDs to operate, and they still weren't very powerful.
A typewriter-like keyboard is the master control, setting out data and instructions on a punched tape, which in turn feeds the electronic computer.
There's a huge effort to make more powerful quantum computers. This used to be the stuff of university physics departments, but you can see the potential when you see who's in the business now. It's big names like Google, Microsoft, IBM. But it's not just about when one day, one company or one lab invents this one computer. It's going to be a bunch of small advances towards the kind that's commercially available, reliable, and can really solve some of these big problems.
Problems that once took the human mind 7 years to solve.
Here's the thing. When we talk about quantum computing, people tend to think of an all-singing, all-powerful machine that can run any kind of program, what's called a universal computer. That's still a distant prospect. But in the meantime, there will be smaller machines, more specific purpose, less general purpose. These things are incredibly hard to run. They're held at temperatures lower than that of deep space in very, very controlled laboratory environments. Even if you could just pick one up off the shelf, you wouldn't. Yes, they're incredibly powerful for some kinds of problems, but they're not going to replace the kind of computer on your desk or in your phone. You don't need quantum powers to edit photos or send emails. In fact, what will probably happen is that a few companies have the best computers, and you can use them on a kind of timeshare basis in the cloud. Or you send off your gnarly quantum problem and just get an answer back. But the kinds of problems that we'll be able to pose, the kinds of answers we'll be able to get, are absolutely unthinkable now. And that's what has governments, industry giants, and plucky startups in on the race.
Diversity of, all different types of diversity.
Exactly.
So not just background or ethnicity, but perspective, I think, is so important to creating the best products, the best ideas, because different perspectives bring different perspectives. You don't even know what you're missing if you don't have different perspectives in there.
Yeah, especially when you're training AI, right? Because you want to sort of make computers think and act like humans, and that's not one gender. That you don't want them to act like humans of one gender and one race and one mentality and one country. You want them to think like all humans. So you do need all the perspectives for this.
I'd like to understand how Seneca is working with Dell Technologies. You have to translate, as you mentioned a minute ago, the scientific requirements for discovery into high-performance computing requirements. Talk to me about how you've been doing that with partners like Dell Technologies.
In our computing architectures, we had the need to address the capability to facing the big data processing involved with respect of the Human Brain Project, and generally speaking, involved with respect of the science-driven that would provide cloud access to the systems by means of containers technologies, and the capability also to address what will be the creation of a federations of high-performance computing facility in Europe. So at the end, we manage a competitive dialogue procurement process that in a certain sense would share together with the different potential technology providers what it could be the visions and also the constraints with respect to the visions, including budget constraints. And at the end, Dell that showing the characteristics of the solution that it will be more, let's say, compliant and at the same time flexible with respect of the combinations of very different constraints and requirements.
Facebook's new AI takes image recognition to a whole new level. Facebook's AI algorithms can watch a regular video and, as it is playing, figure out how to turn it into a fully 3D scene, frame by frame. Faced with a simpler task, say, turning a video of your kid's soccer practice into wireframe models or doing the same thing with a still holiday snap, Facebook's algorithms are considerably more adept. And they're getting way better all the time. AI's next big challenge: playing a quantum version of Go. When Google DeepMind's AlphaGo program defeated the world's greatest Go player in March 2016, it represented a major tech breakthrough. Go, a Chinese board game in which the goal is to surround more territory than your opponent, is a game that's notoriously easy to learn but next to impossible to master. Center for Integrated Quantum Information Technologies, China is using quantum computing to solve this. The U.S. wastes $161 billion worth of food every year. AI is helping us fix that. Based on what we see, supermarket shelves filled with a greater number of food products than ever, it's easy to think that there isn't a problem at all. Except that there very much is. Now, startups are helping hotel and retail industry with AI tools based on historic data. This means reduced waste and bigger margins. This video is produced by Vice of AI. To get more latest news and videos, follow us on Twitter. Thank you for your precious time.
Zuchongzhi 2.1 can perform large-scale random quantum circuits sampling about 10 million times faster than the fastest existing supercomputer. The study was led by quantum physicist Pan Jianwei. The team said this remarkable feat makes China the first country to achieve a quantum computational advantage in two mainstream technical routes. One via photonics quantum computing technology, and the other via superconducting quantum computing technology. The team has also established a quantum computer prototype named Jiuzhang 2.0 with 113 detected photons, achieving a major breakthrough in quantum computational speedup.
The improvement of 113 detected photons from 76 means it is capable of implementing large-scale Gaussian boson sampling, or GBS, which is septillion times faster than the world's fastest existing supercomputer.
The study was published yesterday in the online journal Physical Review Letters.
In the next step, we hope to realize fault-tolerating quantum computing and use quantum computing to solve some major and valuable science and technology questions.
Quantum computational advantage, also known as quantum supremacy, indicates an overwhelming quantum computational speedup that is currently unfeasible for traditional computers. 张悦，上海来福。